Welcome back. We are now working on lesson 29, Circumference of a Circle, Homework Review, Part 2. We're picking up question number 4. And before we start, if you find these videos helpful, any videos helpful, please give it a like and subscribe to the channel so that you can be notified, and turn notifications to be notified when new videos are added. Probably going to make sure you guys go over this question, especially question number 4, in a number of ways. First off, I'm going to do it the same way that they have done it on the video, and which kind of makes sense using trigonometry. I'm going to try and blow up the triangle for you. So this might take a little bit of time. Then we're going to use probably a different method, and then we'll see what the formula they talked about. All right, so the following regular polygon has 15 sides. This distance from the center to any given vertex is 12 inches. Which of the following is the best approximation for its perimeter? Well, in the video, they talk about, in this case, like creating a triangle. Here, in this case, from connecting the center of the polygon to the next vertex over. And so we have this triangle. I'll try to make it a little better. Now, this triangle, because the radii should be the same measure, it's also this triangle. So it'll look something like this. I'll get our triangle here, okay? And so this triangle will have its measurement here of 12 on one side, 12 on one side, and 12 on this side. To find the angle measure in between, we're going to do 360 divided by 15, because there are 15 different triangles can be formed because they're all evenly spaced. So we divide the 360 by 15, and so we're going to get, in this case, I believe it should be 24. So that's 24 degrees. Well, then what happens is that they say, well, okay, let's draw an altitude that goes down from the vertex. Oops. Altitude that goes down from the vertex. All right, and so now that angle is half of 24. So we'll divide that by 2. Divide that by 2. Oh, gee whiz. Wish it was responding for 2 by 2, and we get 12 degrees. Therefore, we're going to have a triangle, a right triangle in this case, where the angle is 12 degrees, and this measurement is also 12. So we want to find this side here, we'll call x. Okay, so, which corresponds to this measurement here, x. Okay, so we would have in this case, the sine of 12 degrees is equal to x over 12. And therefore, the measurement of that side here, of this small slice of a triangle, is going to be 12 times the sine of 12. Which we will discuss in a bit, though. Except there's 2 of them. There's 2 of them here because this whole measurement here is also x. So therefore, one of these measurements here will be 2 times 12 sine of 12 degrees. Oh, sorry, my handwriting's terrible. All right, so, well, you know what? I'll put it here. Okay, so in this case, that side is going to be 2 times 12 sine of 12 degrees. There you go. All right. But there are 15 sides. So our perimeter will be 15 times 2 times 12 times the sine of 12 degrees. All right. So this is how we kind of find this perimeter. We find the measure of the side the way they talked about. All right. In this case, we're using our right triangle trig, and we get this whole thing where we find one piece of the isosceles triangle, which in case of the base, we know what the side of the regular polygon is going to be 2 times that, because it's 2 parts to make that one side, and 15 of them we multiply 15. So we're going to multiply 15 times 2 times 12 times the sine of 12. Okay, so let's do 15 times 2 times 12 times the sine of 12. And before we continue, I want to make sure I'm in the right mode, make sure I'm in degree mode. Yes, we are, so we're good. And we enter together, we get a total of 74.848. So 74.848. All right, so 74.8. We're going to go 0.8, which will round up to 75 inches. So this is going to be the answer we're going to get. So this method that they use, all right, that's one method of doing this. Okay, but there's another method though, okay? The formula they talked about earlier. So let me erase some of the stuff here. All right, so let me make some space here. All right, so they say, what formula? Well, I believe they gave you a formula which said in this situation that P, the perimeter, let me use here, I'll use red. Okay, the P, the perimeter was going to be 2n times the sine of 360 over 2n. But that would be only the measure of, that would be the measure of the perimeter if this side was 1. So we had to multiply this whole thing by, in this situation, the measure of the leg, which in this case would be, I'll call it the r value, r. And so we plug this in, we're going to get P equals 2 times 15 times the sine of, well, 30 over 30 is 12. So we multiply all of that by the measure of the radius, which is 12. And you'll see 2 times 15 times sine of 12 times 12. This equation is the same exact as this equation, just moved around because multiplication is commutative. We're totally good, and we get the same exact answer. Okay, so that's the second way of doing this, using that formula we had, except multiplying the formula by r. Okay, so really, if we want to write this formula out, we write it out as the following. Stop a little bit. That perimeter is equal to 2r times n sine of 360 over 2n, where r is the radius and n equals the number of sides. Okay. All right, so r equals radius number of sides. And this works out for a regular polygon. So, hey, okay, so we have two methods, a formula and I guess step-by-step way of breaking down our work. But there's one other way we can go with, because, you know, why not? Okay, so let me just, erase some of the stuff here, because we're gonna be hoping to get the same answer as before. All right, so let me get my eraser here and let's erase some stuff here and all. All right. Say, well, what could we possibly do? I hope you you guys go back to the video to, and see what it was. No, okay. But I'm gonna go back and we're gonna use something we learned before, the law of cosines. You can use law of cosines, law of sines, either one's fine. So just want to clean this up a little bit. Why am I having time with? There it goes. Let me take these two pieces out here. Yeah, okay. All right. I'm also going to remove this piece here, this altitude, because we don't need it though, okay? So we delete this here. All right. Now, still the same triangle. Still we have 12 inches here. All right, this is 12 inches here on this side. And we calculated before divided by 2, that this angle measure would be, in this case, 360 divided by 15, and we said will be 30 degrees. Okay, and so we want to find this measurement here, x, which is same as the whole thing, x here. And so what happens is the perimeter will be 15 times x. Why? Because all the measurements of the sides of the perimeter will be the same, because it's a regular polygon. And so we're going to find this using the law of cosines. Okay, and so law of cosines, if you forgot, it's been a while. Okay, so law of cosines will give us we have the following formula: x squared is equal to, in this case, the measure of each of the sides next to it, squared, so 12 squared plus 12 squared, minus 2 times the measure of two sides, 12 times 12, times the cosine of the angle included in between. That's the cosine of 30. Okay, and so what we will do now is find the measure of x and then multiply by 15. So bring our calculator, and we'll do now, in this case, 12 squared plus 12 squared minus 2 times 12 times 12 times the cosine of 30 degrees. And we're going to find out that this measurement is going to be 38.58. We're going to take the square root of that, so second square root, and we can insert the answer by second negative symbol. Notice the negative symbol here. And we are able to use our calculator to take exactly what the calculator has stored and use that. So square root of that gives us the 6.211657082. And then we're going to multiply that by 15 because there are 15 sides. And we'll notice that we get 93. Oh, that's weird. Did I make an error someplace? That's strange. Oh, I know what an error is. The angle measure is not 30 degrees, ladies and gentlemen. It should be 24. Ugh. My mistake. So let me just take, let me just actually, like, should we do this whole thing? Sorry about that, ladies and gentlemen. This is what happens when I'm like just too excited and all. And we have the calculator checked though too. So second entry, not that one. Second entry, not that one. Second entry, not that one. Oh, there we go, that one. And I can basically recall the entry here and type in 24 because in this case, 360 divided by 15 is not 20, is 24. And so let's find this answer. 24, that's the correct number, 24.898. Okay, we'll take the square root of that value. Answer there, and then multiply this by 15. Sorry, 15. Almost made no mistake. Hey, it's the same exact answer from before, and it should work out because it's trigonometry, right triangle trig, or in this case, trigonometry law of cosines. Okay, so ladies and gentlemen, it's still going to be the same answer. We still get the same exact thing. So just want to show in this case that there's more than one way to be able to solve these problems. Instead of just using a formula or using a right triangle trig, we can also, if you find using law of cosines, it works out okay. But if you want to use law of sines, this could work out too. In this case, you would have found out in this case not 24 degrees. So let me just erase this here. I'm sorry about that. It should be not 30 degrees, it's 24 degrees. If it is 24 degrees, then you would have to now find the measure of each of the other angles here. So let's see now, we'll take, if you took, we did 180 minus 24, we get 156 divided by 2. We would get each of these angles to be 78 degrees. 78 and 78. You could use law of sines, and you also do the sine of 78 over 12 equals the sine of 24 over x, and use that to be able to find the measure of the side of a polygon, one side, and then multiply 15. So there's more than one way available to us, okay? So just know that you have your tools, and all these should work out pretty well. So believe it or not, this is the end of part 2. We spent all this time with one question. And so if you like to use a formula, please use the formula. If you want to use the right triangle trig, you can. We'll use law of sines, law of cosines. Any method we have available to us is okay, because as long as it's a correct method, if you will. All right, ladies and gentlemen, thank you so much for watching. If you like this video, found it helpful, please give a like. All right, and watch out for part 3. Take care. Be safe.